let me splash it up here. This, of course, makes this a little more difficult. Maybe I need this for later. Two brands of projector. All right, while that's warming up, does somebody have a different question? Oh yeah, you had another one. What was the other one?
76
76. All right, 76 we can talk about. Cool, I like it. So this one is, if you've done this seems like you're in history class, but statistics covers everything. In advance of the 1936 presidential election, before Twitter and stuff like that, a magazine titled Literary Digest released the results of an opinion poll predicting that the Republican candidate Alf Landon, we could have President Alf, any 80s babies especially. What was Alf in the 90s? 80s? 80s? Alf, 8 cats. The magazine sent postcards to approximately 10 million voters, and then approximately 2 million returned the postcard. So there's a lot of issues there, right? So you can kind of in your head already figure out some of the issues, and thankfully that's what they ask you about. Think about the United States in 1936. Why is a sample chosen from magazine subscription lists, automobile registration lists, phone books, and club membership lists not representative? So it's hard for you to imagine. It's relatively recent that even people had computers in their house, and now we have computers in our pockets. It was in the 90s. I remember starting off with internet, and it was a new thing. So you get the page started, you go make some dinner, you come back, it's halfway done. So you go somewhere else. Yeah, and now it's like 3 seconds, come on. But you got to think about 1936. What's weird about those things? What would not make it representative of everybody, right? 1936, did everybody have a phone? Did everybody subscribe to a magazine? No, all right. Did everybody have a car? 1936, they're still relatively new, to be honest. All right, I mean, so that one shouldn't be too evil. What effect does a low response rate have on the reliability of the sample? Again, you got to come up with an idea. You can go back into the section. They talk about low response rates in the section. You can kind of see what they say, but you can also think. If you send out something to 1,000 people and 30 people send it back to you, what might be true about those 30 people?
There's no responsive bias?
Yeah, good. So there's, somebody read this stuff. So there's a voluntary response thing. There's why do people call into radio shows or something? Because they have they have a strong opinion, right? So if you think that they're representative, you're going to think, holy crap, everybody in the world is an insane, mad lunatic. And thankfully, they're not representative, right?
That's how we get Bodie McBoatface.
Bodie McBoatface, exactly. Eventually, they're going to stop requesting people to name things for them. All right. So some of this, of course, is reading. Are these problems examples of sampling or non-sampling error? Okay, so now you go back and you see what's a sampling error, what's a non-sampling error, right? Blah, and then Gallup. You got to love Gallup polls. Blah, blah, blah. Okay, and then that's just really relating that to what kind of sampling method that is in Part D. Is that so? I will point you in the direction of where to go get the answers. I'm not going to necessarily give them to you. But this problem is mostly reasoning it out. 1936, what's going on? Why isn't it representative? And also just definitions, terminology. Go back to the section. What does it mean? Is that cool? That's what that problem really is all about. That's number 76, in case you haven't gotten that far yet. Let's look at this one. Number, what was it, 16? Is this guy awake over here? There you go, sweet. Can you figure out which one of those, try to turn one of those off? That's the one. Stop, stop. Okay, you're good. Thank you. Is the probability that one? So this is number 16. Whoa. All right, Jeff. This is like trying to drive a truck with a trailer on it. If you ever driven something with a trailer attached, you might know what I mean. If you turn this way, it goes that way. What the shit? Okay. So here's the data they give you above. There you go, Jeff. There you go, buddy. All right. So already seen this problem yet? People playing along at home. That's the problem we're talking about. Okay. So it's got data up here. You got to do one for researcher A and researcher B. They give you the classes. Today we're going to actually talk about how to construct these classes ourselves. But how do I get the number that goes here?
Figure out how many go in that slot.
Yeah, how frequently does a data point show up in between these two values? All right, so you just count how many. They gave it to you in not in order, which is too bad. So today we'll also talk about, I forgot. Thankfully my office is right there. I need to grab the graphing calculators because I have a feeling a lot of you guys don't have one yet or couldn't bring it. We're going to work with that today. And one of the things we'll do is get it to give us stuff in order, which is nice. And once you've got these, how to get relative frequency, you just
take that number, and
take that number
by 40.
out of how many total. That's why I call it relative frequency. Another name for relative frequency is just percent. The percent that is in this class. Is everybody with me? Now, real quick word. If you're out there right now and you're like, I don't have a clue, you lost me at freaking number 60. You got to say something. Don't feel stupid saying something because if you have a question, there's at least 8 other people have a question. And a lot of people are doing this and they don't mean this. They just want me to think they mean that. I don't know why. So don't sit there like everybody's doing this around me. They don't know. But yeah, you just count how many show up in here. Relative frequency, another name for that is percentage. The percent that's in there. So you divide this by the total. And cumulative frequency, you just add up as you go down. So it should end up close to 100%. I like it. Is that a decent? Was there?
You did it on Wednesday. You did something like that on
Yeah, totally. Yeah. Was there something else about 16? Let's see. And then they ask you questions about it, starting at 17. Is that decent?
Yes, I just wanted to know about the frequency. In the first thing they say that the survival length in months. So how can I find it in the researcher page, for instance?
So like all those numbers, 3 is 3 months, and then 4
Yeah.
months and 11 months. So all those numbers represent months.
Thank God. Right. Yeah, that's it. So use those numbers to fill in this table. Yeah.
Okay.
Were you going to show us on the calculator how to put it numbers in order to this? For this thing, you said you were going to do it at some point. Is this at some point?
Today is the point.
Today.
I'm not going to do it for this problem.
Right. Okay.
Because I don't like doing homework. I did my homework. Okay. You had one more question, right?
Yeah, 88.
88 sounds familiar. I think that's a weird medium question or something. No, okay, this guy. All right. This is the old adage about lies, damn lies, and statistics. So this is just, all right. There's not much here. It's very surface level stuff. What is immediately a problem with these graphs?
Not labeled.
Labeled in terms of what? Good. All right. So there's no English. They don't tell me what they are measuring. One could be measuring something per year and the other's per month. At least as important as that is, there are no whats that are always on a graph. There are no what?
Numbers.
How tall is this?
Numbers. Yeah.
There's no numbers. So this could be 1, 2, 3, 4, 5, and that's why it's so tall. This could be 5, 10, 15, 20, and it's like, well, that ain't fair. You'd be surprised. So, not that blatant, but they're very often, and it's not necessarily on purpose, but people try to compare two things, and they have the scale doesn't start at 0, they're different scales. Little things happen, and then that makes things look much worse than they really are, or they skew it in the direction of what they feel. You guys see what I'm saying? So there are multiple ways to represent data incorrectly, right? And you maybe didn't do it on purpose, but if you're going to compare two things, the scales have to mean exactly the same thing, or else what good is a comparison, right? If one's daily and one's monthly, how can you get away with comparing them? Is that decent? So again, it's not normally that blatant, but there are little things people can do on purpose or just purely innocently that will skew comparisons, right? And nowadays, oh my God, when even the truth isn't the truth anymore, you want to be able to discern, or at least know what to look for to know if you can even compare what to talk about, right? If you're paying any attention at all nowadays, it's scary times. Okay. Is that decent? You guys are? Okay. Anything else from homework stuff? Yes. Those are some big ones. All right. Please, dear God, if you haven't started the homework, this is bad. You should have started it by now. If you don't have the book yet, yes you do, right? You just download the PDF online, not a big deal. You don't have to download it, just sit next to the computer, just do the homework. You can get it. You can get a hard copy again if you want to through Amazon. There's a link on our website. Cool, I like it. So I like that a lot of people turn homework in, that makes me feel better. I was worried. So nothing else from homework stuff? Yes?
Question 21. I know it's really simple, but they say to give some examples of, I don't have the examples. Okay, so how might the research gather random data?
That's totally...
I know what they mean, like random samples certified or whatever. But the book at the end gives an example of random sample, like how they supposed to
Yeah, it's just one possibility.
My question is, do they mean like how do they gather random data from their particular for their particular sample, or it's about the sample or it's about the population?
So I think the way the answer they give us worded is they do it relative to their own data.
Okay,
which doesn't make sense.
Yeah,
it doesn't make sense. I would say you should come up with your own way for them just to gather the kind of data they have.
Yeah.
Yeah. You could say throw a bunch of, I think this one was about AIDS patients, right? So you could say throw a bunch of AIDS patients' names in a hat, take them, take every AIDS patient from several selected hospitals, that would be cluster, right?
So it's not about their sample.
Yeah, the book, as if they're what's called resampling, like sampling from what they already sampled, which they don't really make that specification. So if you answer that question from a purely how would they get the data in the first place, that's beautiful.
Okay, and if you answer...
Yeah, the other way is fine too, because that's what the back of the book makes it sound like.
Sometimes I'm lost.
I understand. Yes, everybody can, they're all like, you're not alone. And that's why I allow you to ask questions. So it's better to be lost right now than to not have even started going anywhere. Okay. Anything else before we get back into where we were last time? Okay. So I think the last thing we did was the table of stuff. So I want to remind you about stem and leaf plots, and then we're going to talk about histograms. Okay. We're still in the section where we just are displaying data. Here's what I got. I haven't analyzed data yet. Pretty soon we're going to do mean, median, mode, that kind of stuff. But right now we're not even sinking our teeth into it. We're just displaying what we see. All right. So stem and leaf plot. I think the book just calls it stem plot, which makes it sound less interesting. I like stem and leaf.
Stem leaf makes more sense.
Yeah, you got both parts to it. Because that kind of reminds you how to do it. Stems, and then you got the leaves coming off your stems. So if I had this, all right, it's not a very large set of data, but just to get the idea out there. Okay, I like it. You actually have a couple of ways you could do this. Your stem, it cannot, let me just cut to the chase here. Your stem cannot be 1, because then the purpose of this is lost. If your stem was 1, then you have 21, 27, 36, 38, 40, all coming off of that 1, and it's not showing you how things are distributed. So who has a suggestion as to what the stems should be?
Point.
Yeah, 1.2, right? 1.3, 1.4, and if there was a 1.5. You see, so you don't want the stem to be a single thing, because then the purpose is lost. It's like, I already have a list of the data. Why would now I'm going to put a list of data with lines around it. Yeah, no. I want to distribute. I want to kind of see how they fall among several possible values. So you got to be a little smart as to how they give you the data. You can even do it without the decimal, as long as your key explains how to read it. So what would come here, of course?
1 and then 7.
What will come off of him?
6, 8, 9.
Yeah, so this is decently, let me say this word, this is going to come in our future soon, uniformly distributed almost, except there's just less up here. There's nowhere that it's clustering. It's a very small set of data, but my only point here was to show you what you can do. You could have done this without the decimal places, as long as in your key, and with us, it's kind of easy to read. This means what? It means 1.21. I like it. Now, if you don't want to, you don't have to do it. I could have done all this without those. As long as my key captures that means 1.21, then people know how to read it. The key is integral. If you forget it, you're going to lose some points. I like it. It's like not telling me the scale on a map. These look relatively close. They're a day apart. Oh, shit. Tell me that, right? Okay, how we doing? So that's just a little stem and leaf. Now let's look at histogram. I'm going to give you a completed histogram, just so you can see what it looks like. See if you can reason out what the parts of it are. So we got this here. Sure. So now we got histogram. Just going to use quantitative data. Qualitative data would be in a bar graph. Men, women, bar graph. They don't have to be connected. This has a truly numerical scale. Quantitative, remember, quantitative is truly numerical. Truly numerical. So let's say I have somebody made a histogram and it looks like this. Let's do one more. I don't know. All right. So creative I am. This is ages of people. Let's see. So let's say, super. Let me just get your take on what's happening here. How can you tell this is done correctly? What should happen with Let me ask you this first. All right, let's start off with this. How many classes do you think are represented up here?
5.
Why do you say 5? I like that. Average those 2. There's 1 class,
Oh, 4 classes then.
2, 3, 4.
Oh.
Right. There's 4 major groups represented up here. That's the classes. Classes are from 5 to 15, 15 to 25, so forth. I like it. Now, just to kind of prep you, where's 15? If I had a 15-year-old, which class do I put him in? Can you tell right now? No. Okay, so that's going to come out in the process of putting this together. 15 is going to be in the second class, and you'll see when we make it how we do that. But you see how there's a problem there? I can't really have a class be 5 to 15 and the other one be 15 to 25, because where's the 15-year-old go? Do you guys see the problem? It's like, do you double count them? No. Do you not count them at all? That would suck. So number of classes, there's 4. What's the class width? 10. I love it. 10 years. Kick ass. They're all 10 wide. Right? They better be consistent. So 10 years. I like it. Kicking the ass in. What else can I ask? What percentage from 25 to 35? 50%. I love it. Okay, right. And of course, the total percentage of everybody, thankfully, is 10, 40, 90, 100%. Yay. Okay. I didn't create people. I had 10 people, now there's 11. Whew. No. Okay. Everybody feel pretty decent about that? Pretty decent? Kind of decent? Let me see, what else can I ask you? There's not really much. Would you say this is normally distributed? Let's see if anybody remembers what that means. Not really, right? It's not even really roughly. What's normally distributed mean?
When it looks like a traditional bell curve.
Bell curved, it's symmetric, it starts low, goes high. So you can say this is really, really roughly, because it does start low, go high, and go low, but it's not really symmetric, right? So there's some issues there. I like it. Okay, maybe. Okay, so let's talk about how to create our own, and then I got a little group worksheet for you guys to work on. Yeah. Let me ask you this. Can you tell what the lowest data value was? What's the youngest person?
Yeah.
So if I said, how young could the youngest person be? 5. There's nobody below 5 represented. But can I tell if there are any 5-year-olds?
Yes.
Were there any 5-year-olds? Can you tell? Can't tell. I know that 10% of them were between 5 and 15. They could have all been 11. Or they could have all been different ages. They could have all been 14. Does everybody see? This doesn't tell me what the data values were. They just tell me what percentage were between 2 things. I have no idea if there were any 5-year-olds. Cool? All right. I like it. Okay, that's good. So let's get into creating our own histogram. And I would like to use you guys, the data you give me on the survey, so please fill that survey out. Please. Or else you're going to have me making stuff up. I like to use actual data from you guys so you can see where you fall. All right. So I think I'm going to give us some data that's in order already. We'll talk about how to construct a histogram. I'll get you guys started on this group worksheet, and I'll run back and get the calculators. So we can talk about how to use it. All right, so here, let me give you guys some data. Let's say these are IQ scores. Why not? All right, that's good.
So 107, 107?
Yep, totally. Oh, yeah. I mean, it's totally possible. I don't know why Tuttle, it's like Tuttle. totally possible to have two people with 107 IQ. It's got to be represented in your data. You represent repeats. You don't lose people. Everybody's got to be there. So I definitely want to make repeats happen so you realize that they're different people. They have to show up, both of them. It's not a very large set of data, but you want to be able to do this relatively quickly. Now, there's a very physical aspect behind what we have to do here. Can somebody tell me what the range of the data is? What's the range? What do you guys think the range is?
65 to 130.
All right, good. I like it. So, and the range in statistics is a number. It tells me how far the data ranges. So it does go from 65 to 136, which is how far? 71. So the range is 71. That's how many IQ scores, the range of IQ scores it covers that I see in my data. So range in general is high minus low. I like it. First little dinky little equation. Now, let's say that this is the 65-foot mark, and this is the 136-foot mark, just to pretend. Right? And I want to, now the whole idea here is that histogram I had earlier, there couldn't have been a 3-year-old because it wasn't up there. I've got to cover the entire range. Now, I made a histogram that had 4 classes. That's not enough. I don't know if you guys remember. It has to have at least 5 up to 10. For us, we're almost always going to use 5 or 6. The larger the sample, the more classes you would use. I'm not going to give you busy work and give you 180 data points. I mean, that's just busy work. That's insane. So if I have to cover from here, let's say I love the 70s. I want to put wood paneling up here for some reason, just so people can't use the whiteboard because education that's done and over with. So I want to cover this with wood paneling, right? And I want to use 5 panels of wood. How wide would each panel have to be so that I'd cover the whole thing? I could overcover it, that's fine, but I have to be able to cover the whole thing. So if I use, now think, this is a physical idea. I know I've got to do 71.
Yeah.
That's 71 feet in this case, right? Pretend like that's 71 feet. So how wide, if I make each panel this wide, is it going to work to use 5 panels? 1, 2, 3, oh shit. So I want to go into this knowing how much to have them cut the paneling. I'll use 5 panels because 5 is my favorite number. I don't know. So think about it. Don't say anything out loud. Can somebody come up with how wide each panel? Could each panel be 5 feet wide? Obviously not. Be 70, 75, 80, 85. I wouldn't make it up to 136. So think about it. You could do it. How far do I have to go? 71. And I want to use 5 panels. So you can think of it like steps too. How big does each step have to be? If I take 5 steps and I want to be way the hell over there, how big does each step have to be? That's how big each panel has to be. Can you guys do that? What do you have to do? Divide. So the width, the class width, which is how wide each rectangle is going to be, my wood paneling, is going to be range divided by number of classes. Does that make physical sense? I mean, if I had to go 80 feet and every step I took was 4 feet, how many steps am I going to take? 80 divided by 4. So this is definitely a division. At this distance divided into 5 panels tells me how big each panel has to be. What is 71 divided by 5? 14.2. So you always round up. I want to give the person a nice whole number. And we want to work with nice whole numbers. We don't want to. Sometimes you might not be able to if it's really, really tight data. But normally for us, we're going to use round numbers, whole numbers. So round this up to 15. So if I use 5 panels and they're all 15 feet wide, how many feet is that going to take me? 75 feet. So am I going to cover the entire range? Yes, I'm going to overcover it, which is fine. I just want to cover the whole thing. I want to have a place for every data point to go. How are we doing so far, you guys? So there are physical ways to think about what we're doing mathematically. There has to be, because math is fundamentally a way to represent the physical world. Whatever, Jeff. All right.
Why would we put 5 number of the classes?
Yeah, so the number of classes is always going to be 5 to 10. We will almost never use 9 or 10 classes. We're going to be on the lower end because I'm not going to give you this huge sample to work with. The book is going to be nice. The book is going to tell you how many classes to use. I'm not going to be nice. I'm just going to make it, just to get you guys used to the fact I'm an evil person. Okay. So everybody got this? I'm going to take this away. Everybody realizes a quiz this Wednesday. Probably a quiz next Monday also. Next Wednesday. We got Monday off. And don't forget the survey, please, dear God. All right, let's make this histogram, and then I'll finally stop talking and let you guys work on this group work. So first thing we have to create is the frequency distribution. And we'll actually create a relative frequency distribution. That's just the table, right? The frequency, relative frequency. So I've got to come up with these classes. The classes like the 0.5, the 30.5, the 36.5. We have to come up with those classes ourselves. So tell me, what's a good number to start at for this data? 65 is amazing, right? You don't have to. You can start at 60 as long as 65 has a place. You can't start at 66 because then where the hell is 65? But let's start. It's a good idea to start at the actual number. I'm going to show you the way the book does it, and then I'll show you a way that I do it, that I was taught, that's better in a few ways and worse in a few others. So I'll let you choose which way you want to do it. Now, where's the next class? So I'm going to 65 to something. Where's the next class have to start if our width is 15?
80.
80. It's got to start at 80. Because how far apart are the classes supposed to be? 15. So if one starts at 65, the next one's got to start at 80. Does that make sense? So do you understand why this cannot be 80? Because then where the hell would 80 go? So this is the book way of doing this. And it's a little bit messy, in my opinion. I don't care which way you do it. If you do it my way, you're not going to get brownie points or any shit like that. Right? But here's what you do. Yeah. So then, now what can you do? How far apart? That's 15, so you add another 15, you add another 15. Right, you add another 15. Woohoo! And now it's just one below, so 94, do you see that? 109, pow! 124, pow! And if I add 15 to this, I end up at?
140.
Careful. Add 15. 15, not 16. 15. 139. All right, let me stop right there. Let me show you the other method on the side. The reason people don't like the other method is because it has inequality symbols and it's got a little X that shows up, and everybody goes, I was told there wouldn't be much algebra. Come on. We can handle inequalities, please, dear God. But you can do it this way if you want to, but then you got the weird shit going on. You got some other weird shit we got to talk about later. The way I would do this is to say this class goes from 65 up to almost 80. This one goes from 80 up to almost 95. Which class does 80 go into? This one's got to be less than 80, but this one includes 80. Do you see that? And do you see how I can see the 15 right there? Here it looks like 14. A little liar. But you see, everybody see why we had to do this? Maybe. Does everybody see either one of these? Please see either one of these. If you don't see either one of these, come see me. Pick the way you like, stick with that way. This way has another weird shit you got to worry about when you go to make the picture. This one doesn't. I am sort of pushing you this way, aren't I? But you can do either way. I don't care. But do you notice how they both represent the same idea, don't they?
Yeah.
It's just that if I had decimal data, this is much better. Where would 79.27 go? In this first one. Where did 79.27 go here? Oh, shit. I don't have a place for it. You have to go out to decimal. That's screwed. All right. What's this next column here? Good. Freak. So how many 65 to 79? 2. 80 to 94? 1. 95 to 109? 1, 2, 3, 4. 110 to 124? 1. And then the rest? 2. All right, not too bad, right? So, I like that. That's symmetric. I didn't really do that on purpose. I can't claim that. I was thinking ahead. No. What's the next column over? The real frequency. The relative frequency. How many data points do I have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Ooh, I got 10. That's neat. I didn't even try it. So does this look good so far?
Yeah.
What do these add up to be? Thank God. So do a real quick check here. If you have 10 data points, these better add up to 10, or else you left somebody out. If they add up to more than 10, you created a person, which is like, that's some weird shit. I mean, well, we can create people, but don't create people in the middle of a homework problem. Like it's free. 3, 7, 10. How do I get the relative frequency? Yeah, 2 tenths is what percent? 20%. You got to love when it's out of 10 or something nice. So 20%. This will be 10%, 40%, 10%. All right, and of course those add up to be 100. They didn't have to round anywhere, so that's why it's so nice. We've done that before. The new thing so far is making your own classes. So you got to figure out the class width. You got to figure out where do you want to start. You got to figure out which way you want to represent it. That's the new thing so far. We've done the rest of this stuff. There could be cumulative frequency. I don't really care too much about that. So any questions so far? Any questions at all? Please, again, I don't know. You have to trust me or else why would you be here if you didn't trust me? If you have a question, at least 8 other people have the same question. If they don't look like they do, they do. Right? Is everybody good so far? All right, so let's make this histogram, and then I'll let you guys do your own stuff here. Let me see. I'm going to take this away. Has everybody got this here? I would hope so. So, the major... now watch. If I start to make this, if I showed you a histogram and it had like an empty space somewhere, what would that indicate?
Nothing.
That there's a class that has nothing in it. Nobody was in it. Mm-hmm. If you do 65, 79, 80, 94, do you see how you're going to have all these gaps? Mm-hmm. That is a lie, right? Did we leave people out? Hopefully not. All right. So there is a problem that we have to take care of. And you're going to love the way you have to take care of it. If you do it the inequality way, that would just be 65, 80, 95. It would be beautiful. Another little push towards the inequality way. If you do it this way, oh, shit. Let me explain this. There's a limit to me, right? Like I stop being Jeff like right here on my skin. Right past that is not Jeff. You with me? So that's the limit. These are class limits. These are class limits. Then there's a boundary. There's a boundary. If you tell me something, you're standing right here, and you're like, Mr. Waller, I'm like, you're a little in my boundary. You're up in my grill. Step back. There's a boundary around me. You guys with me? And you're all like, I don't know what you're talking about, Jeff. Tell me I got bad breath. No. So the boundary is going to be up and down by a half. And now watch what that does. Where's 80 go down to?
79.5.
See how they line right up? There's no gap then. If you push them up and down by half, there won't be any gaps between. Also, how far apart is 64.5 and 79.5? 15. There's the width. There's that hidden width. Right? You're like, that looks like 14. Well, no, it's actually 15 because you got that invisible boundary shit. Okay. Normally, now I'm putting it up here, but don't even put these up here. I'm just showing you what they are. Don't put them in the table. Put them on here. If you do it the book way, your graph better look like this. It better have the up and down by half. And I just keep adding 15. Is that right? Yeah, good. 124.5, 139.5. These are ages of people, right? Yeah, I think it was. Thank you. No, it's IQs, wasn't it? IQs. Again, if you do it the inequality way, 65, 80, 95, beautiful. The limit is the boundary for the, I don't know why more books don't do it that way. My book did way back in the day. Some of the old school stuff is better. Some of you guys know that. Musically, for sure. Let's do a relative frequency. Now, if I ask you to make a frequency histogram, you would use these numbers. If I ask you, most of the time I'm going to ask you for a relative frequency histogram because that's the one that's a little better. So if I do a relative frequency histogram, what should my scale be? What's the highest I want to get up to?
20? 40.
40. So then naturally maybe I should just use, especially because everything's 10, 20. I was using 10, 20, 30, 40. Now for some reason people will go up to 100. And then your picture looks like this. It's like, okay, you got space. Why would you do that? Zoom that sucker up, right? You only go as far up that will include the highest one. There's no reason to go up to 100. You got a lot of white space then that is losing some resolution then, okay? Now's the easy part, finally. How tall should the bar be here?
20.
Yeah, 20. Pop, and then 10, and then 40. Whoa, Jeff. And then 10,
20.
20. Looks like the picture is sort of flipping us off, but oh well. Got big knuckles here. It's like, all right, statistics. What the shit did I do? It's definitely symmetric. You could say it's very roughly normally distributed. The main reason why it is not normal is it doesn't start low. It starts medium, low, high, low, medium. It's not. But it is nice and symmetric. If I took a larger sample, maybe more people would populate here, and then it would be nice and symmetric. Who knows? IQ scores are normally distributed by design. Yes?
Say if you were trying to graph it the other way when you put your algebra formulas, would you have to put anything in between the numbers?
No. Like if I was using, you mean like this here?
Exactly.
Yeah, it'd be 65, 80, 95 on the scale.
And then that equation, you want to put it in between each one, or just that?
Which equation? I'm not.
Less than X.
No.
This guy. Then, like I said, it would just be 65, 80. Nothing in between. It's beautiful. The limits are the boundaries here.
So wouldn't you only have 4 classes then if you did that?
No. 65 up to 80. 80 up to 95. 95 up to 110. 110 up to 125. 125 up to 140 in this case, yeah. So there'd be the same number of classes. You're representing the same range of numbers 2 different ways. So of course they have to have the same number of classes. Is that cool? I like it. Up to you which way to do. So if I did it the other way, it'd be 65, 80, 95, blah, 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 blah. Same exact picture. How would this picture change if I used frequency instead of relative frequency? How would the picture's shape change? Not. It wouldn't change, of course. This would still be twice as high as this, right? This would still be four times as high as that. It'd be the same shape, it'd just be a different scale here. Yes, in this case, nice, it would be 1, 2, 3, 4. Yeah, sorry. All right. So, any questions on that? All right, so let's do this. Let me shut up.